All right. Another practice problem. I particularly like this one. Good illustration with a few limitations of how molecules of a compound differ from the molecules of an element. This is sort of a intro to chemistry first chapter material. I did not create this problem. I retrieved it from the Brown textbook, 2012, The Central Science. So we have four pictures here, A, B, C, D. We're prompted with the question, how do the molecules of a compound differ from the molecules of an element? Some keywords: molecules, compound, versus the molecules of an element. So in picture A, we see atoms of an element, and this is, as we're learning this terminology, semantics, atoms are these discrete individual particles. Notice for the element, there is only one type of atom. They're arbitrarily colored red here in picture A. In picture B, we see we're still looking at an element, but this time molecules of an element. And they provide this sort of text box that informs us why it's an element, and that's because only one kind of atom is in or is present in any element. So in choice A, though it's discrete single particles, it's only red, so one particular type of atom. Elements can exist as single atoms, that is true. Other elements exist as molecules, where you have two atoms of the same element. In this case, it's element blue, let's call it, bonded together. So we call that a molecule. So, three important terms that will stick with you through the rest of chemistry. What is an atom? What is a molecule? What is an element? So that's two valid ways of phrasing. You can have atoms of an element, or you can have molecules of an element. In choice C, we first see the word molecules. We know what that is. That's going to be two or more things chemically bonded together. Two or more atoms, I should say, chemically bonded together. In choice C, we're looking at molecules of a compound. So, as denoted by the text box, compounds must have at least two kinds of atoms. So, we can have molecules of an element, but by having the word element, we know that it's only one type of atom. When we introduce the word compound, we know that we're talking about a chemical structure where there are at least two kinds of atoms chemically bonded together to form a single molecule. So here, the illustrative compound, the green atoms, three green atoms bonded to one central purple atom, make up one molecule of this compound per green, purple, whatever we want to call it. This chemical bonding that's taking place between the green atoms and the purple atom to form a molecule of the compound. Lastly, in choice D, or picture D, sort of brings it all together. We see individual red atoms. We see molecules of the blue element, two blue atoms chemically bonded together to form a molecule of the blue element. And then we see two molecules of the compound, the green and purple atoms bonded together, three green atoms per one purple atom, all in this one defined space. And so because they're existing in this space together, we call that a mixture. And a mixture, in this case, you can have a mixture of compounds, and you can have a mixture of elements. In this case, we have a mixture of both elements and compounds. Mixtures are a study in and of themselves. This is an inch in towards the mixture terminology, but you visually see the components of a mixture. So this is a good, definitionally relevant schematic as we're learning chemistry terminology, molecules, compounds, elements, and to an extent mixtures. We see it denoted in the figure titled Molecular Comparison of Elements, Compounds, and Mixtures. The textbook answer to this question, I have it textually here at the bottom in quotes. So to answer the question, how do molecules of a compound differ from the molecules of an element? The textbook would say that molecules of a compound are composed of more than one type of atom, and molecules of an element are composed of only one type of atom. Now, a further clarification to that last definition, you can have molecules of an element, but also remember that you can have elements that exist as discrete individual atoms. Just a note to make.